Now we're going to get into the life cycle part of the operations and maintenance, DMLS roadmap. So the SEPS project was called the SEPS Strategic Plan. DMLS was a roadmap for Department of Defense military health system. And we have proofs of concept here as well too. One opportunity we saw as we were getting into this is that this was running in parallel to what was happening with SEPS. There are a lot more challenges in DMLS FM in that it was not being updated. The technology is not being updated to a newer version, so it's still based on an older system. So essentially it's a step behind SEPS. But we wanted to see what alignments there could be with SEPS, because essentially it's the same data. Now we're taking the data that we use for design and construction requirements. It's ending up in the field, and field technicians are having to deal with equipment, for example, and working on work orders, which today is still a very disconnected process. Work orders are captured and then back to a desktop, enter the work order into a system, and then deal with a work order. So it's a back and forth kind of chain to a computer rather than to a mobile application. If you can imagine this DoD-wide, we actually did a calculation, I think it's even up here in the later slide. If you multiply the times it takes to walk back and forth to deal with just the work order itself, and you multiply it through DoD, it's a lot of time and money and budget being used on this. But also from a technician's perspective, these are the guys that could care less about BIM in many ways. They might see, in some cases you might want to have a 3D model and walk up and find things. Yes, that's very valuable. A lot of cases they're just trying to fix things, and they're out in the field, and how do they deal with information? And we've seen this with community colleges as well too. There's some that are would be more interested in BIM and other technologies. Others would might as well just keep on going the way that things are done. So it's a challenge as well. There's more of a cultural shift, but also it's a question of how much technology and data is useful today. There's overkill sometimes if you think that everything has to be in a detailed 3D BIM to manage turning a screw on a piece of equipment to fix it. In some cases, yes. In many cases, no. So the answer, in other words, is not always we'll just deliver a BIM to the owner, because a lot of owners are struggling with that today. When they get the BIM delivered to them, first of all, it doesn't have the data that's needed. Second of all, they can't even open up the model in the native format. So it's that hump that we're trying to get over as an industry. Then now we're working with BIM. How do we deliver the data back to the owner that they can actually manage the facility? In the meantime, while you're in operations and maintenance of facility, all this data is churning through this constant change, massive amount of information and data and work orders and things happening and renovations happening and equipment that's not up to date, for example, and how do you track it? How do you track problems? All a moving target. The only real solution, again, if you go back to that Yelp application, imagine a Yelp application that you could pull up information about a facility like this. So that was one of the visions that we have, or the Google Glass now, for example. And ultimately, yes, all of this stuff that's happening in a building is related to the building and is related to the detailed BIM, if a detailed BIM exists. But if you imagine a detailed construction model being delivered to an owner like this, and then having to maintain it inside that model, it's a challenge again, unless you have tools that allow you to touch the data without having to understand what BIM is about. So as you repair and replace things, how do you update the data in the model? So for DMLS, we also said the strategy is similar, although it's a little bit different, because we said, okay, DMLS FM, the current version of DMLS FM that's managing the millions of square feet worldwide for DoD. The good thing about DMLS is that it is DoD-wide. The challenge is that there are different variations and ways that each site works with it. So that is a challenge that we have to deal with. We also can't just switch it off and say we're going to switch to another system tomorrow, because it's used in day-to-day operations. So the strategy on this particular project was look at what's happening with SEPS, but also use the same approach, web service enable the data, but don't turn off the old DMLS FM system until we start testing it. So start hosting the data in 3.5, create a platform, do all that stuff, but it's not going live until we start testing and development. And we want to test and develop it really quickly. And then once it's up to a certain point, we're saying in 2015, for example, and there are a lot of challenges there. It's not going to necessarily happen overnight, obviously, but we think that if you stretch it out too far, it's already, I think we've established that it's collapsing on itself as far as the current weight of DMLSS and technology and the challenges are just not there to manage facilities in a way that you need to be able to have total asset visibility and all that.
You have to do something.
You have to do something, yeah. So this is the part about cannibalizing yourself in some ways, that you have to look at the value. There's value in the system. There's a lot of knowledge and a lot of effort that went in over the years, and it was a great solution in 1999 or 2005 or maybe even 2010, but fortunately we're pushing it. But so that's where we kind of started with that. So we said let's start developing it, testing it here, and ride on top of the back of what's happening on SEPs, because the data and the approach is no different if you're planning and designing a facility with data about a facility. And now, I mean, planning, then programming a facility versus now you're in operations and maintenance. There's different stakeholders involved, but it's the same type of stuff that you want to touch. So we identified the current, web service enabling it, expanding development platform. There's a current CAFM system for managing the plans of facilities, which is, we were challenged to go and review the current tools and see if they can transition into this future state. So we've had a lot of discussions with vendors of how can they take current systems and make them more services oriented. In other words, don't trap the data into one application. Let us get to the data, because if you're managing floor plans of a building and that floor plans has square footage about a space, it's not only valuable to you as a CAFM application, it's also valuable to portfolio level view of how many square feet of exam rooms do I have. And that same data has to exist in multiple places, whereas right now it's not. It's really, if a roll-up has to happen, it's a monthly kind of a call to servers all over the place and aggregating. It's not real time. In other words, you can't say find all of my restaurants in the area like on Yelp. You have to kind of do it. So that's the opportunity and the challenge there. The current system being used for CAFM, we're saying, what happens if we want to go more towards BIM and GIS? Can we use the current system, or is it time to have a discussion about how do we transition into a future system? And that's not identified yet, but we went through a process of saying that we need to identify other solutions as well as talk to the current system and see if it can transition. And then once all of this is functioning, once we have the data decoupled, the web services enabled, the applications developed, test applications and actually functioning applications, then we decide at one point to switch off the old system and basically transition it to the new one. Basically taking the data out of the old, leaving it behind and moving it into the new. That would have to happen almost overnight. We can't stop operations. So it's a moving train. How do you track the moving train? Unfortunately, the current moving train is bundled into an application that's very monolithic, heavy, expensive to maintain. Every time a new field needs to be added, for example, it's hundreds of thousands of dollars to say we need a new field, a new pull down or something like that, which shouldn't happen. That should be pennies, really, if you think about what we talked about with Max.gov. You just plug it in a different module, and you don't stop the train from moving. You kind of plug things in as it moves along. There's a professor at George Mason University that actually talks about this quite a bit. And this is not a jab at any of the current software vendors. It's just the way that things were. But now is the time to have a discussion about, we don't want monolithic systems. It's not a business strategy to kind of trap owners' data into it. Coast Guard identified that years ago. How do we transition? George Mason professor said, a lot of the systems that are currently in place or that were built by consultants that basically welded systems together and then watched systems with blowtorches to make sure the weld didn't break. Basically this black box, which means that could only be maintained by one group. That is no longer acceptable, and that's what this project was about, to identify that we have to move away from that if we want to even think about moving to the next generation. So that's the goal for DMLSS. And the alignment with SEPs, we're saying SEPs is already moving, it's already going to Max.gov, it's already doing a lot of the things that we want to happen in DMLS, so we don't have to reinvent the wheel. There's no reason to say we're going to build a whole different approach. Sorry about that. That we want to build a different approach. We want to say, let's use the same approach with DMLS that we're doing with SEPs, and make sure our audio is still working. Young, we're still okay, right? You weren't just trying to call me. Sorry. Okay, we're okay. So that's what's happening. Again, the agile approach that Andy talked about as well. It's this short cycles. If something doesn't work, you can throw it away. You haven't spent a year development. You haven't spent a couple of weeks. You throw it away. You try another piece. And in the proofs of concept, we actually walk the walk. We basically said, here are actual functioning first versions, proofs of concept that actually work with your data that were done in a few weeks in some cases. So we actually we plugged in a work order system that's on a mobile application that was developed. We plugged in applications that already existed and said, if we had DMLS data, here's what it would look like in the life cycle. And that's what we'll go into next. So conceptually, we also looked at, this is a little hard to read, but if you think in terms of a project that on the upper left, program, planning, design, construction, that's a very important piece of what happens in design and construction projects. And a lot of the focus in the industry today is about how do you share data between the design BIM and a construction BIM and the different consultants and different tools and things that are used. That all important stuff that's happening. But that's really a point in time. If you look at these verticals as years, every year that goes along in an operational cycle, it's constantly churning. And really the project is a point in time. It's really insignificant in the terms of the multi-year management of facilities. And that moving train has to keep on going. So systems underneath it need to be maintained. And then we need to cut across. So we said, if the data that's being used for design and construction can be parked into a server, and that's web service enabled, then other applications can use it for work order systems. So we can pull from a work order system, for example. You can't place a work order unless you can say where it is in the building, which goes back, you can't place a work order in a building unless you have consistent naming and numbering in a building, which no owner that we've run into has, except for the California community colleges. Some owners are starting to approach that, but it's still a huge challenge. So if we can't get numbering and naming correct, everything else really doesn't matter, no matter how great a BIM you have or whatever. So we're saying, if we do that, we can start slicing across. And then when you get into the next phase, then at the top level, you have the portfolio level. How much is it costing? How much is the roll-up for our portfolio? How many square feet do we have? Here comes a project. Here comes a moving train moving along. We have to deliver the project into the moving train so they can use that for operations. And then we have a renovation project coming off to the right. So these instances in time need to plug into the overall approach of we're managing facilities. So all this complexity that you're seeing here, this looks really like just a lot of stuff layered on top of each other. It's already being done, but it's being done in a manual and inefficient way, which means a huge waste of resources again. And really what we want is we want a simple way to get to the piece of data that's relevant to our piece and not be bothered with the rest, but we know that we're tied into the rest of the system. So the end result is to simplify, to allow the users to actually get to their work and create kind of a genetic code of the facility, and to be able to ask questions like, what's it cost, how's my schedule doing, and have an answer for that one-button approach. If we can't get to that one-button approach, we're just wasting resources building things that will not support the need of an organization. So that's one of the big goals of DMLS-FM. We looked at the different modules in DMLS, the current modules of room inventory, RPIE inventory, maintenance procedures, budget management, all these different things that have to happen. If we decouple the data, right now it's kind of tightly bundled so you can't get to the information. If we decouple it and we say, we also want to layer it in on top of SEP, so as you're planning a facility, the name of a space matches what ends up in operations and management, at least have a common ID, then you're able to kind of compare it across, and you're able to build future functionality. That's the other big thing, is that once you break the data apart, you're not only building it for a single use, you're actually making it accessible to other uses, just like that Yelp application. You can start stacking, okay, we want to add transit directions, we want to add ratings of restaurants, we want to add a way for you to add your comments about what your experience was in the restaurant. All that, the technology is a no-brainer today. It's already there today. So how do we apply it to this? And also to isolate it just to the piece of information I want. So I want the concept of big data, like we've all heard. There's massive amounts of data being produced out there. It's only meaningful when you can get to it and analyze it and find that pattern. For example, NSA, finding patterns in communications. Why not use that same thing of finding patterns in the data that's run through our facilities to make those decisions? But we can only get there if we can structure it in a way that makes it accessible to everybody. Model servers, we talked about model servers, so a lot of different pieces. This project, we were jumping all over the place, life cycle, but the common theme was how do we constantly just get data out of all these systems, disconnect it from the application, make it accessible to other applications rather than be tied to a single place. Publishing data out through web services, making it accessible in many formats. I'm going to kind of speed it up here a little bit. Again, connecting SEPs with DMLs, the SEP side from the left, DML side from the right, and also looking at the current workflow of a typical project. So we have SEPs requirements. We have those requirements handed off to the design team who uses BIM, CAD applications. We have some GIS applications that talk about location. Then it needs to get into operations and maintenance and DMLs. And we have CAFM applications for looking at floor plans and operations. And there's roll-up, JMAR's a roll-up, how's our portfolio doing? And there's a lot of connections today. What are happening? It's you're passing a file from one to the next. Here's my output from SEPs, Excel. Here's inputted into the design team, exported out to DMLs, a lot of manual entry again. Some automation starting to happen with standards like COBie and IFCs. Those are connections of, again, file exchanges pretty much. Great stuff happening. It's a good beginning, but it's still kind of, we're looking at one project and not kind of an ecosystem. So we're saying if we take all of that and we split it apart, sorry, this text is kind of small, but if we take all these elements and we say, okay, instead of having this passing over the fence each time, strip the data away from the application. So don't think of it as I'm in BIM or I'm in GIS or I'm in programming. It's basically you're in data. And when you're in data, you break these silos up so you don't have classifications of different turf wars that happen typically of don't touch my data because you might break it. You break those silos, you pull the data out and you create that information layer we talked about, and then you get all the applications to subscribe to the data. So whether you're using GIS or FM or BIM, you can then subscribe to that data about what number do we call the space, a fundamental foundational piece that everybody needs, for example. And then it doesn't matter what application you're using. The application becomes irrelevant at that point, and security is layered on top of all of this. And this, we describe this as, again, the genetic code of facilities. You don't really classify things by what application you're using. You're just classifying it by the type of data, and then you access it from many different users and many different end applications up there. For example, BIM, CAFM, computer-aided facility management, and SEPs for programming. They're all using the same type of data as long as they can get to it in a consistent format. Okay, sorry, I'm kind of speeding through this now because we're kind of getting a little bit long here. Are there any questions? I could take a couple questions and I'd have to repeat it for the audience here. We could jump back in later. Unfortunately, our audio up here is not working, but I'm running through a lot of stuff here real quickly. Any questions? Okay. All right, so that's the big data concept of facilities. All right, and the user is coming from the top. Service-oriented architecture, breaking apart that instance of passing files back and forth and using it as the target being 2015 of getting to a state where we can actually share data consistently across applications. And the end goal is get the data that's needed to that user and not bother them with the rest of the complexities of the technologies. Just make it as simple as that Yelp application. Data I need, I want it now, I want it when I'm mobile. I don't want to be bothered with anything else. And I want to be able to get my job done with it.
Sure. So Kimon's been showing you the facility side. Inherent within the facility, both on the DoD and the VA, is the medical devices and equipment services, where they maintain the calibration and all the services to make sure that the facility and the medical devices equipment maintain their DACO accreditation. That is a key part of what these applications provide as a fundamental service. So as he was showing the picture of the technicians being able to find the equipment, service it, document that it's calibrated, that it's certified, that is a key functionality that these applications have to be able to do. And so where this is becoming even more important with the SEPs and DMLs interface is the VA and the DoD are now beginning the development of a number of joint projects. And Lloyd, you want to talk about maybe Chicago or El Paso or any of the joint efforts. But this is where now DoD and VA have got to look forward into the next generation of healthcare provision. How do you go out and provide those veterans and the active duty service members that level of health care that's going to be required?
Yeah. Right. I'm going to repeat your question for the audience online. Sure. So it's Todd from the State Department, and you're looking at your 19,000 facilities and how you would data warehouse it and make the data accessible, and what are the key successes for making it work. Essentially, that's the question, right?
Yeah,
right. The question is how does BIM fit into feeding data into that data warehouse like that and making it accessible to directors and others that might not have access to BIM. And I haven't gone into a lot of detail, but there's a lot of proofs of concept in these projects that talk specifically about that you have that BIM that's used for design and construction, and a lot of the data in there is useful for operations. But if you think in extreme terms, go back to California Community Colleges, if they had 5,200 highly detailed BIMs, accessing the data in there, first of all, it's important data, but you don't want to have to manage one model at a time. So the concept of model servers, for example, how do you get the data out into a server to make it accessible, whether it's a BIM server or any other kind of server that serves facility data. The other important thing, which goes back to the community college work, you don't necessarily, it's not necessarily putting it all into one database, because you can't imagine, the internet is not one database. It's a collection of servers that I can basically mash up and plug in. I want a database about restaurants, and I want access to data about traffic, and I want about the weather, how do I get, all that stuff is kind of merged together, and then the application interface, the user interface in the end is basically accessing the data underneath. And the only protocol you really need at that point is a web services type of an approach or an API that says, I want to get today's, the temperature right now, and the schedule right now, and the restaurant reservation, and I want to buy it on my iPhone. Decoupling it and making it kind of loosely coupled like that allows you to mix and match different things together. Now, obviously, another thing that happens, which kind of goes back to the security concept, in BIM, you can put everything in BIM, right? Conceptually, you can put people in it, you can put schedule, all kinds of stuff in BIM, and then you put it on your laptop and you walk around with your laptop. That's the worst security risk there is, to put stuff all together in one place, where in this web services approach, you only are exposing a piece of it, and then that's what you're compromising, is just that piece. So there's a lot of discussions in this project, which we don't have a lot of time to get into, but Mike did a lot of the work on the security side, that there's already stuff happening elsewhere in government, and DoD and whatever, about security and about mobility, and how do we deal with it. So from a technology point of view, there are a lot of answers already out there. We don't have to reinvent the wheel, and that's part of the reason we're here today. We want to kind of say, let's share this out and see who else is running into these issues and what pluses and minuses are there. I'm sorry, that was kind of a long answer to your question, but right. The comment was that to distribute it sometimes, not sometimes, a lot of times makes sense, but you can still have large data warehouses of things. But it's what Andy was talking about as well too. In fact, it's, you don't, if you another one I use a lot of times is the airline model. When I go into Expedia, I'm hitting the Delta schedule and the American Airlines schedule and their price, and then I'm bidding, buying a ticket. They're exposing their price, they're not exposing their business strategy of how they got to that price. So you can have a very kind of modular way of saying who gets access to what. You're not necessarily, it's not a free-for-all, in other words. It's a way to actually control it more. When you build it in modules like that, you can start, even on the fly, for example, with Coast Guard years ago we talked about this, is if you have information about your facilities that are a security risk, yes, you don't want to have people access it, but in certain scenarios, in a 9/11, you might switch it on and say emergency responders, public might even have access to the floor plan. No, you never know. But if you can't access it, that's the worst security risk. The worst security risk is not having access to the data that you need when you need it. So 9/11 is not necessarily because, it's not because you're trying to keep the bad guys out of it. It's the good guys don't even have access to information. So once if you decouple it like this, you can mix and match and do whatever you want with it, and it creates a better secure environment. The worst thing, I think, again, is not having access to information is the risk factor for the right people. Then you can't make informed decisions, you can't have a total asset visibility, all that stuff comes into play. So all of this is kind of talking about that. How do we create these, instead of having one big bucket and everybody does that, which, by the way, vendors love. If they say, give me all your data, we'll put it in our bucket, we'll put a big black box around it, and we'll maintain it for you, and you'll love us. Yeah, right. So that's, that doesn't work anymore. So that's as an owner, that's what California Community College basically said, is we own our data. We're going to put it in this database. We're going to give you the rules of how you can access it. And if you can't do this, it becomes very black and white. There's no marketing stuff in the end. It's more, can you or can't you work with REST web services? You can, well, great. Here's how you can get to it. And that works very, very well for them, because there's no time to kind of go through kind of marketing pitches about how it works or doesn't work. And that's one thing we set up for this project, is we really want to see other solutions and other vendors out there of how they link into this, because there is value. There's a lot of value and knowledge in the vendor community. It's just that we have to flip the rules around a little bit. Okay, so we kind of are going a little bit over here, but I think I'm going to skip through some of these slides and kind of hit towards the end here. Let's see, a couple of these are kind of important. So we then looked at BIM at different levels of detail. So if you imagine this on a web interface, on a desktop BIM application, on a mobile application, we want to get to that piece of equipment. This is one of the functioning proofs of concept. It's a combination of our tools and Google Earth and the BIM tools like Revit and ArchiCAD and other databases and systems kind of tied together, and being able to do this portfolio level view. I'm designing, constructing a building, but I'm a user that knows nothing about BIM. I want to see the same chair and the same attributes about that chair as I'm managing that facility. And I want to be able to communicate and check across. And then I want to do a roll-up all the way up. We even showed free tools on the lower left. This is actually an interesting example. Doing roll-ups for demos is, well, how many square feet of whatever do you have, right? We said, okay, we can actually take the public data that's accessible about locations of DoD facilities that's publicly accessible, just park them on a Google Fusion server open, because it's public anyway. And then we can create dots on a map with, these are all free tools that years ago used to cost tens of thousands of dollars to do. And then you can start layering, now you need a login to get into the floor plan, so you can start drilling down into it. All of these examples, by the way, we've created publicly accessible examples with open data. It's all sample data, so we can actually drill all the way to the building. If that's the other invitation we have, is any vendor out there or any consultant wants to show how they can connect to the system, we're inviting. And as part of this work here, we actually had a lot of examples of that. Scheduling of rooms. Okay, we use OASIS standard. There's a scheduling standard. Okay, why don't we use that standard? We want to use the standards that are out there and plug them into this. So all these standards that are being developed are very important to be able to do things, to be able to tie into building automation systems and sensors. We had 5 different vendors say they wanted to show how their systems tied into this. So we said, okay, turn on web services, show us your data, pull up a plan, there's sensor data. It's really kind of a plug and play approach that we built to that. iPad applications, which I'll show live later on, so I'll skip over this, but going and scanning. Right now, to get to a piece of data about the demos, it's that guy walking back to the piece of equipment, typing it in and then going back out. Why not pull it up on an iPad? There's no reason that already exists, and you can create simple apps with that as well too. I'll skip through some of these. Scheduling, security layers, again, color coding, using the floor plan as a dynamic generator of a heads up kind of a view of where the secure levels of rooms in a building. And constantly looking at how does this tie back. So even if you're working with desktop applications, we're constantly looking at how does that data tie back into the server, tie back into the portfolio level view, tie back into web services, so others can use the same data in other formats. So this is kind of the ROI thing that we did. We actually had an actual number, DoD-wide, there's 783,000 work order requests in 2012. Being conservative and saying it takes 10 minutes to do that and 20 minutes to go back to the desk and 30 minutes to enter it and go back and forth, we were very conservative about the number. We said, okay, it's about 70 minutes, which translates to 114,000 man days at $113 million a year of what it costs right now. And if you say, well, if we reduce that by 20%, if you didn't have to walk back to the desk and you use a mobile application to get to that data and you multiply it out portfolio-wide, it's a huge number. And there's a lot of other activities like this that are happening. But work orders were easy to kind of identify, but it was just one of the potential ROI things that we saw of the reduction in time if you had access to this instead of walking back and forth. Okay, let's kind of speed this up. I think we've seen some of these slides, so I'll kind of skip through these. Young, I know that people online have a hard time kind of hearing everybody talk here, but are there any questions from anybody online? Or I'll try and repeat questions that we have here. Are we okay?
Kimon, the questions I'm putting in your Skype.
On Skype, okay. So questions from online. What specific benefit has a VA derived at what cost? Not quite sure what that means. What specific benefit has a VA derived at what cost? I'm assuming it's talking about the SEPS project again, because VA is involved with the SEPS project, but I think I might need a clarification on that, unless Renee wanted to. It's hard to tell what that means. Any questions from in the room here?
I have one that might be a similar squishy.
Yeah, as far as the ROI, the question basically is how do we establish the ROI, and how do you get people to come along for the ride on that? It's actually a very difficult discussion, because as soon as you start talking about cutting time, it kind of gets translated into FTEs, things like that. But really, what we're trying to say is, if you shift the focus, it's about survival. And then, if you don't use mobile applications and you keep on going the way you are, you're not competitive anymore in managing facilities. There's no reason to not do that. And we had to try and find some numbers. We looked at broad numbers. How many work orders do you do, or how many hours does it take to enter data into SEPS to define a program? What happens if that becomes web-enabled? Right now, for example, in the previous version of SEPS, because it was based on a laptop, what they did is they install SEPS on a laptop, go to a meeting, and then have to pass the laptop around to others to enter their requirements into a laptop. That's one way it's done. So there's a lot of inefficiencies in the current workflows that sometimes are hard to identify specifically. Like, how could we have imagined a few years ago, how efficient are we going to become with these? I mean, it's just massive, and nobody thought, well, on iPads, okay, whatever. But it's changing everything. So I think things like the work order system were one place we identified benefits. The cost of development of a lot of these softwares. We wanted to show that there are ways to build these applications for pennies on the dollars, whether we do it as a prototype or whether another consultant comes in, or whether it's done in-house. It really doesn't matter, because you're not having to build that whole infrastructure. And there's a lot of inertia to make that change a lot of times, because it's a challenge when you start bringing those kind of discussions up. But I think that's, and I see this as a vendor as well too. I think a lot of owners don't even know what to ask for, because they're used to just getting, well, this is how it's always done. So it's a chance right now to kind of shift that and force the discussion and look at that ROI. But Clay, I don't know if you have anything to add about ROI.
No. What you just, I hadn't seen what you just put up there. You think about how much money is just sort of not obvious to folks. And it's every day, every place, it just adds up to see your conservative estimate there at $113 million. I mean, that's real money.
Right.
And how do we actually affect those savings? Is it, does that free up existing FTEs to do other things? Does that mean we need fewer FTEs? Does that mean we, how you actualize those savings is hard for people, I think. It's hard for me, at least, to get our heads around. But they're real. It's real money. And the fact that we can articulate it here, I think that's an important step to getting people's attention. And then that just invites us to, okay, let's explore that further to see, okay, what do we do about it now?
Right.
But until you see that, you just accept how we do business as just, well, that's just how we do business, and it costs to do business. But that $113 million, that, you talk about being competitive, and oftentimes the VA and the DoD sometimes don't think of them as being competitive, need the necessity of being competitive, but in fact, at DoD, I can tell you that we do need to be, and that cost is embedded in our unit cost of whatever it is we produce, whether it's a bed day of care, or whether it's an exam room visit, or whatever, that overhead is embedded in that.
Right.
And that makes us less competitive inherently.
Right.
So to frame the argument in those terms, and to actually ascribe that unnecessary overhead cost to whatever our unit cost may be, I think is a potentially very valuable tool for us.
Right.
I mean, State Department doesn't have to compete, but they've got I presume the same sorts of issues.
Right.
That, however they do their cost accounting, it's real, and because it doesn't hit you all like when we do an appropriation, a line item appropriation to go build a facility somewhere, everybody sees 113 million. No, that's a lot of money. Okay, it's just the same amount of money here, except we don't see it in the same way. We don't appreciate it.
Right.
And how you get people to grasp the importance of it and appreciate it, and then the impact it has, and then okay, what do we do about it? To me, that's work to be done, but you can't do that until you have the tools.
Exactly.
And this level of analysis, which I think is great.
Right.
This will get, in our world, this will get people's attention.
Right. Right. I see a couple of questions that you just sent. Andrew Arnold asked, for healthcare FM, continuous uninterrupted service is a customer requirement. How is DoD and VA dealing with this requirement in context of distributed services? Any response to that? How are we dealing with it? Well, this is, I could put a short response here. This is part of the plan here, is how do we deal with it? It's, we're trying to identify, yes, it's important to have continuous uninterrupted service because it's critical to the operations. Barry Yacht asks, if all this data will be connected through a single enormous interlinked system, will we always be able to prevent damage from viruses or other threats to the data? We always have to be aware of that. It's not going to be a single enormous database or a single enormous system. That's the whole point of web services, that it can be distributed. Just like the internet is, you can turn off part of the internet, the other part keeps going. It's kind of the same concept here. We obviously have to structure it and build it up to avoid that, but it's actually less vulnerable than the way it is right now, because right now it is a single system and it does go down for minutes or hours at a time, which is no longer acceptable in this day and age too. So if you have facility management systems going down for even minutes, it's no longer acceptable. Obviously Google and Amazon and others have downtime too, but it's much less downtime than the current way that systems are built and managed. All right, so for those online, thanks for joining us. We're gonna eat over here. Sorry you're not here to join us, but we've talked enough, I think. And we'll continue with questions and discussions here if anybody wants to see more. And I'll show some live things on the iPad if anybody wants to see. We'll be showing that as well.